Cincinnati.GE Aviation, a subsidiary of General Electric, is headquartered in Evendale, Ohio, outside Cincinnati. GE Aviation is among the top aircraft engine suppliers, and offers engines for the majority of commercial aircraft. GE Aviation is part of the General Electric conglomerate, which is one of the world's largest corporations. The division operated under the name of General Electric Aircraft Engines until September 2005. GE Aviation's main competitors in the engine market are Rolls-Royce and Pratt & Whitney. GE operates two joint ventures with Snegma of France, CFM International and CFM Materials. History. Early efforts. General Electric had a long history in steam turbine work, dating back to the 1900s. In 1903 they hired Sanford Alexander Moss, who, in time, started the development of turbo superchargers at GE. This led to a series of record-breaking flights over the next 10 years. At first the role of high-altitude flight was limited, but in the years immediately prior to World War II they became standard equipment on practically all military aircraft. GE was a world leader in this technology. Most other firms concentrated on the mechanically simpler supercharger driven by the engine itself, while GE had spent considerable effort developing the exhaust-driven turbo system that offered high performance. This work made them the natural industrial partner to develop jet engines when Frank Whittle's W-1 engine was demonstrated to Hap Arnold in 1941. A production license was arranged in September, and several of the existing W-1 test engines shipped to the U.S. for study, where they were converted to U.S. manufacture as the IA. GE quickly started production of improved versions. The I-16 was produced in limited numbers starting in 1942, and the much more powerful I-40 followed in 1944, which went on to power the first U.S. combat-capable jet fighters, the P-80 Shooting Star. Early jet engine work took place at GE's Syracuse, New York and Lynn, Massachusetts plants, but soon concentrated at the Lynn plants. On the 31st of July 1945 the Lynn plant became the Aircraft Gas Turbine Division. GE was repeatedly unable to deliver enough engines for Army and Navy demand, and production of the I-40 was also handed to Allison Engines in 1944. After the war ended, the Army cancelled its orders for GE-built J-33s and turned the entire production over to Allison, and the Syracuse plant closed. Military and civilian expansion. These changes in fortune led to debate within the company about carrying on in the aircraft engine market. However, the engineers at Lynn pressed ahead with development of a new engine, the TG-180, which was designated J-35 by the U.S. military. Development funds were allotted in 1946 for a more powerful version of the same design, the TG-190. This engine finally emerged as the famed General Electric J-47, which saw great demand for several military aircraft. A second manufacturing facility near Cincinnati was opened. J-47 production ran to 30,000 engines by the time the lines closed down in 1956. Further development of the J-47 by Patrick Clark in 1957 led to the J-73, and from there into the much more powerful J-79. The J-79 was GE's second hit, leading to a production run of 17,000 in several different countries. The GE and Lockheed team that developed the J-79 and the F-104 Mach II fighter aircraft received the 1958 Collier Trophy for Outstanding Technical Achievement in Aviation. Other successes followed, including the T-58 and T-64 turboshaft engines, J-85 and F-404 turbojets. The TF-39 was the first high-bypass turbofan engine to enter production, entered into the C-5 Galaxy contest in 1964 against similar designs from Curtiss-Wright and Pratt & Whitney. GE's entry was selected as the winner during the final down select in 1965. This led to a civilian model, the CF-6, which was offered for the Lockheed L-1011 and McDonnell Douglas DC-10 projects, although Lockheed later changed their engine to the Rolls-Royce RB211. The DC-10 continued with the CF-6, and this success led to widespread sales on many large aircraft including the Boeing 747. Another military-to-civilian success followed when GE was selected to supply engines for the S-3 Viking and Fairchild Republic A-10 Thunderbolt II, developing a small high-bypass engine using technologies from the TF-39. The resulting TF-34 was adapted to become the CF-34, whose wide variety of models powers many of the regional jets flying today. In the early 1970s, GE was also selected to develop a modern turboshaft engine for helicopter use, the T-700. It has been further developed as the CT-7 turboprop engine for regional transports. Commercial aviation power plants. In 1974 GE entered into an agreement with Snecma of France, forming CFM International to jointly produce a new mid-sized turbofan, which emerged as the CFM56. A 50/50 joint partnership was formed with a new plant in Evendale, to produce the design. At first sales were very difficult to come by, and the project was due to be cancelled. Only 2 weeks before this was to happen, in March 1979, several companies selected the CFM56 to re-engine their existing Douglas DC-8 fleets. By July 2010, CFM International had delivered the 21,000th engine of the CFM56 family, with an ongoing production rate of 1250 per year, against a 4-year production backlog. The success of the CFM led GE to join in several similar partnerships, including Garrett Aerosearch for the CFE-738, Pratt & Whitney on the Engine Alliance GP7000, and, more recently, Honda from the GE Honda Aero Engine Small Turbofan project. GE also continued development of their own lines, introducing new civilian models like the GE90, and military designs like the General Electric F-110. GE Aviation Today, then GEA, were selected by Boeing to power its new 787. GE Aviation's offering is the Gen X, a development of the GE90. GE Aviation also has a 2-year exclusivity on the Boeing 747-8. The Lynn facility continues to assemble jet engines for the United States Department of Defense, subsidiary services and commercial operators. Engines assembled at this plant include the F-404, F-414, T-700, and CFE-738. The plant at Lynn also produces the -3 and -8 variants of the CF-34 regional jet engine, the CT-7 commercial turboprop power plant, and commercial versions of the T-700 turboshaft, which are also called the CT-7. The Evendale plant conducts final assembly for the CFM International CFM56, CF6, as well as LM6000 and LM2500 power plants. The Durham, North Carolina facility conducts final assembly for the GE GE90 and CF34 power plants. Crucial parts for these engines are crafted in secondary GE Aviation facilities, such as those in Bromont, Quebec, Hooksett, New Hampshire, Wilmington, North Carolina, Madisonville, Kentucky, and Rutland, Vermont, where the engine blades and vanes are manufactured. Smiths Group and General Electric announced on January 15, 2007 that the former was divesting Smiths Aerospace to the latter for GBP £2.4 billion. GE Aviation closed the transaction on May 4, 2007. Smiths Aerospace, which was an important supplier, became an operating subsidiary of GE Aviation known as GE Aviation Systems. This acquisition will reportedly give the combined unit the clout to resist pricing pressures from its two largest customers, Boeing Commercial Airplanes and EADS Airbus. Analysts further assert that it enables General Electric to acquire assets similar to those it desired in its failed bid for Honeywell in 2000, along with the purchase of Smiths Aerospace. The purchase included opening the first University Development Center at Michigan Technological University in Houghton, Michigan, in the effort to work with engineering students to provide training in engineering and software development. The program has performed well, and GE Aviation has announced further UDC openings at Kansas State University. In July 2008, governments in the Persian Gulf reached agreements with GE to expand engine maintenance operations there. The Wall Street Journal reported that Mubadala Development Company, which owns Abu Dhabi Aircraft Technologies, an overhaul and maintenance company, signed an agreement worth an estimated $8 billion with GE. Abu Dhabi Aircraft Technologies will maintain and overhaul GE engines used in commercial aircraft purchased by airlines based in the Persian Gulf. On December 23, 2012, GE announced that it has agreed to purchase the aviation business of Avio S.p.A., an Italy-based manufacturer of aviation propulsion components and systems for civil and military aircraft, for $4.3 billion US. Recently, they have started incorporating 3D printing technologies in their engines and have incorporated the manufacturing process in the newly designed GE9X, the largest jet engine in the world. Products: turbojets J31, J33 with later production by Allison, J35 with later production by Allison, J47, J79, CJ805, J85, CJ610, light and low bypass turbofans CF700, F101, TF34, CF34, F404, F110, F118, YF120, cancelled bases for F136, CFE738 with Honeywell, F412, F414, F136 with Rolls-Royce, HF120 with Honda. High bypass turbofans TF39, CF6, TF34, CF34, CFM56, F108 with Snegma, GE90, GP7200 with Pratt & Amp Whitney, Gen X, Leap X with Snegma, GE Passport, GE9X, Turboprops, Profans CT7, GE36, T407, T31, GE, Walter H80, General Electric Advanced Turboprop Engine, Turboshafts T58, T64, T700, CT7, GE38, vehicle propulsion LV100 with Honeywell, industrial aeroderivative and marine propulsion LM500 derived from GE-TF34, LM1500 derived from GE-J79, LM1600 derived from GE-F404, LM250 derived from GE-TF39 and CF6-6, LM5000 derived from GE-CF6-50, LM6000 derived from GE-CF6-80C2, LMS100 derived from GE LM6000 and frame gas turbine.